One of the most common ways we measure angles is using degrees. Now, one complete revolution around the circle we say is 360 degrees. So if I want to go all the way around the circle, that's 360 degrees. That's one revolution, which would mean that half of a revolution would be 180 degrees because that's half of 360. And a quarter of a revolution would be 90 degrees, that right angle, because that's a quarter of a revolution, a quarter of a circle. So let's figure this out. Let's say I wanted to know what 2/3 of a circle was. How many degrees are in 2/3 of a circle? So I have my circle here. I'm going to start right there. And I don't want the whole circle. I want 2/3 of the circle. So about there-ish. That's how much of a revolution I want. But I want to know exactly how many degrees that is. Well, it's pretty easy to figure out. We just multiply. I want 2/3 of a full revolution. One full revolution is 360 degrees. So I multiply those together and I get that 2/3 of that is 240 degrees. So that would be the measurement of this. Now let's try another one. Let's say I only want 1/12 of a revolution. That's pretty small. Something like that. So I want 1/12 of a full revolution. And I multiply those together and get that that is 30 degrees. Makes up 1/12 of a revolution. Now, in degrees, we can actually go even smaller than this. We can measure degrees in decimals. And there are two ways to do this. We can either do decimal degrees, so where we have like 30.5 degrees, that would be halfway between 30 and 31 degrees. Or we could do degree minute seconds, the DMS system, which is also just a way of dividing degrees up into smaller bits. Now, you might ask yourself, why would degrees need to be smaller? I mean, 1 degree is already pretty small. If I have a full rotation and I only want to go 1 degree, that's already a really, really tiny amount. Why would I need to go fractions of degrees? Why do I need to be that specific in my rotation? Well, a few jobs that need to be that specific. First one that comes to my mind is a pilot. If you're a pilot and you're flying in the air, and you're flying from, I don't know, Salt Lake City to Paris, and you are supposed to make a rotation of, say, 30.23 degrees. If you're flying to Paris and you make that rotation 30.24 degrees, you're not going to end up in Paris. You're going to end up somewhere very different. Basically, anytime you're talking about really long distances, you need to be really specific with your angle or you're going to be way off from where you wanted to go. Another good example, astronauts. The math to get an astronaut on the moon has to be very specific. If you are 0.001 degrees off, you are not going to land on the moon. So those are a couple examples where we need to be really specific about our decimal degrees. We need to go down to the 10th, the 100th, the 1000th, and be exact in our degrees, in our measure of rotation. So, like I said, there are two ways we do this. We can either just put our degree as a decimal, 30.5, but that gets really hard for instruments to measure in real life. It might be really difficult to measure 0.001 degrees. So another way we do this is the degree minute second system, where we break it up. And we say that 1 degree is 60 minutes, and 1 minute is 60 seconds. Now, one thing you need to keep straight in your head. When I say minutes and seconds here, I'm not talking about time. They use the same word, but this is actually a measure of rotation, not a measure of time. So 1 minute is 1/60th of a degree. It's a very, very small fraction of a rotation of an angle. So don't think of this as a measurement of time here. They're the same words, which gets kind of confusing, but it is different. So let's do a couple examples where we practice converting between these two. This first one is in decimal degrees, and I want to convert it to DMS. So I want to convert it to something degrees, something minutes, something seconds. This second one is in DMS, and I want to convert it to decimal degrees. So it'll end up being 117 point something or other, turning those into the decimals. So let's start with example 1. Let's convert this into the DMS. First thing you're going to do is the whole number is your degrees. This decimal part is the part we're going to break down into the smaller bits. The decimal part becomes how many minutes and seconds those instruments on the plane should rotate the plane very minutely to make sure we land where we want to. So we're going to start by taking this 0.125, and this is in degrees. And the thing is, I don't want it to be degrees, I want it to be in minutes. So I'm going to do a conversion. And we're actually going to do a lot of conversions in this class. Anytime you do a conversion, you start by multiplying, but by what I like to call a complicated looking 1. Here's what I mean by a complicated looking 1. Let's say that I want to convert from inches to feet. So I know that I have 50 inches. I want to convert that into feet. You would probably instinctively divide it by 12 to get how many feet you need. But what you're really doing is timesing it by 1 foot over 12 inches. This is your complicated 1. Might not look like a 1. 1 divided by 12 doesn't seem like 1. But 1 foot is the same thing as 12 inches. So we do have the same thing on top and bottom, which would simplify to 1. So in this case, we're multiplying by that complicated 1. And the reason we do it this way is because now I have inches on top and inches on bottom. They cancel each other out. And now the only thing I'm left with is feet. So I put that 50 over its secret 1, and I just multiply across. 50 times 1 gives me 50. 1 times 12 gives me 12 in the denominator. And feet is the only units I have left. So 50 divided by 12 would be how many feet this is. That's a conversion. We multiply by a complicated looking 1. We make sure that our units cancel so that we have the units we want left over. So now that we've done that, let's go over to here. I have degrees, but I don't want degrees. I want to end with minutes. So I'm going to put degrees on bottom and minutes on top so that then I have degrees on top and bottom and they'll cancel. Now I need to fill in my complicated 1. I know that 60 minutes is the same thing as 1 degree. There's my complicated 1. They're the same thing, so they simplify to 1. Then I have degrees on top, degrees on bottom, so they cancel each other out. And I'm just left with minutes. That's all I have left. So I go into my calculator and I do 0.125 times 60. And that gives me 7.5. And it's going to be minutes because that's the only unit left. By the way, same thing I did here. Technically this is over 1 and you just multiply the numerators together and the denominators together. So I now know this is 7.5 minutes. So I'm going to take the whole number 7, make that my minutes, and then I'm going to take the decimal part, which is in minutes, and use that to get my seconds. Once again, we're taking those little tiny decimal rotations and breaking them up into fragments so that we can rotate minutely the right amount to get us to where we want to be. So I take this 0.5 minutes, and now I'm going to do a conversion to convert the minutes into seconds. So once again, anytime we do conversions, we're going to multiply by a complicated looking 1. But this time, the units on this complicated looking 1 are going to be different. I want minutes to go on bottom and seconds to go on top, so then my minutes will cancel on top and bottom. I know there are 60 seconds in 1 minute, so there's my complicated looking 1. I know that my minutes cancel because they're on top and bottom. And I can put that over my secret 1 and just multiply across. So 0.5 times 60 is 30. And seconds is all I have left. So that is my seconds. So essentially what we're saying is 42.125 degrees. This decimal degrees is the same thing as 42 degrees, 7 minutes, 30 seconds. That is the same amount of minute rotation. This just allows the instruments in the plane to measure it more accurately to get you where you want to go, to make these tiny itty-bitty adjustments in the air so that they land in the airport they're supposed to. Now that we've gone one way, let's go the other way. Let's take DMS and convert it into decimal degrees. So I'm going to take my 117 degrees, and what I want to do is convert the minutes and the seconds back into degrees, so then I can add them all together. So first thing I'm going to do is take that 15 minutes, and I want to convert these minutes into degrees so that I can add them together. If it's not the same unit, you can't add it together. It's like trying to add apples and oranges. Can't combine them unless they're the same unit. So I'm going to, anytime I do a conversion, multiply by a complicated looking 1. And remember, I want to convert it into degrees. So I'm going to put minutes on the bottom so they cancel. And I'm going to put degrees on top because that's what I want to get. I know there are 60 minutes in 1 degree. There's my complicated looking 1. Now the minutes cancel because I have those on top and bottom. And look at that. I am just left with degrees. So I have, multiply across, put that over my secret 1. 15 times 1 is 15. 1 times 60 is 60. And now this is in degrees because that's the only unit left over. So 15 minutes is 15/60ths of a degree. Now I want to deal with my seconds. So I have 45 seconds. But once again, I want this to be in degrees so I can add them all. They're the same unit. So I'm going to multiply by a complicated looking 1, do my conversion to convert this into degrees. I want seconds to go on bottom, so they'll cancel. Now I'm actually going to put minutes on top because I know there are 60 seconds in a minute. There's my complicated looking 1. Seconds cancel, top and bottom. And I have minutes left over. However, minutes is not what I want. I want degrees. So I'm going to multiply by another complicated looking 1. This time I'm going to put minutes on bottom, degrees on top. I know there's 60 minutes in 1 degree. There's my second complicated looking 1. So then my minutes cancel, and now I am just left with degrees. So I put this over 1 and multiply across. So 45 times 1 times 1 gives me 45. 1 times 60 times 60 gives me 3,600. And degrees is the only unit I have left. And now that these all have the same degrees, the same units, I can just put them all and add them all up in my calculator to get 117.2625 degrees. And that's how we go from DMS back into a decimal. Remember, they're the same measure of rotation. We're just measuring it in different ways. This allows our planes instruments to be a little more specific. So now that we've talked about the DMS system, in the next video, we're going to talk a little bit more about complementary and supplementary and practice finding those complementary and supplementary angles.